Today's lesson, we're going to talk about Bernoulli trials and binomial distributions. What's the Bernoulli trial? Bernoulli trial is when you have experiment with only two outcomes, either success or failure. The example, most common example that you will have for Bernoulli trial is going to be flipping a coins. Either you're going to get head or tail. So let's say getting a success, we're going to use the variable P, and failure is going to be Q. And when we go down a little bit further, they gives you computations how you're going to find out the probability in the Bernoulli trials. And what's the C stand for? C is, if you recall from other sections, that's going to be computations. And again, P is going to be success and Q is going to be failure. N is going to be number of the outcomes. Number of trials. And so if you're not really understanding what C stand for, remember computations. This is the computations right here, right? So that's what you can use. So this is kind of factorial. We have to recall that we know what factorial is, right? Because computation is n factorial over r factorial times n minus r factorial. So factorial is start multiplying from the given number all the way to 1. Again, if you don't remember how to use them, please look for computations and permutation sections. Okay, so if we wanted to go start with example 1, it's a find the P, which is success, and Q, failure, for a single roll of fair dice where the probability of 6 turned up. So what's the probability of getting 6 when you're rolling a dice, right? So then probability of getting 6 is going to be the success one. You have total of 6 outcomes, and getting a 6 is going to be 1 out of that 6 outcome. So the probability of getting 6 is going to be 1 out of 6. So then what is Q? Q is going to be then what is not getting a 6, right? That's going to be 1 minus getting a 6. That gives you 5 over 6. What about the second one? If we roll a fair dice 5 times and identify a success in a single roll with a 1 turning up, what is the probability of a sequence SFF, SS will come out? What's the S and F? S is success and F will be failure. So what they are saying is get the probability of getting success and failure, success on that 5 times. So in other words, you're getting P, Q, Q, and PP. How many success we have? We have 3 success and 2 failure. This means, remember the success was 1 out of 6. Failure is a 5 out of 6. And that gives you 0.003. So this is the probability of getting success, failure, success, and success when you're rolling a dice 5 times. Okay, this one, example 3. If a fair dice is rolled 5 times, what is the probability of rolling exactly 2 threes? So let's use the formula this time. So A, exactly 2 threes after rolling 5. So your N is going to be 5. Your X is going to be 2. And probability of success is going to be each time it will be 1 out of 6, right? Because it's 6 sides, getting a 3 out of 6 is 1 over 6. It means your failure is going to be 5 out of 6. And then the first problem is asking exactly 2. So exactly 2, you're going to do combination of 2 out of 5 times success to the square and failure to the 5 minus 2, so will be 3 third powers. This gives you 5 factorial over 2 factorial times 5 minus 2 factorial, so it will be 3 factorial. And 1 out of 6 square and 5 out of 6 cube. And when you plug in those numbers into the calculator, you will get somewhere close to 0.161. So that's going to be a probability of rolling exactly 2 threes when you're rolling fair dice 5 times. So let's look at the second one. This time it's asking least 2. Least 2. When it said least 2, the x can be equals to 2, but also 3, 4, and 5, because you're rolling a 5 times. You could have 3 2 times, 3 times, 4 times, 5 times. That's what least means, right? So this value, you could say x is greater than equals to 2, right? So the probability of x greater than equals to 2, which this is same as getting probability of x equals to 2 plus probability of x equals to 3 plus probability of x equals to 4 plus probability of x equals to 5. So you need to do all this 4 times, right? But if you don't want it to do that, there is another way of doing it. As you can tell, you have 2, 3, 4, 5 out of getting 0 threes and 1 threes. So not getting greater than equals to 2 is smaller amount, because not getting 2, 3, 4, 5 times is going to be 0 times or 1 times. And since instead of doing all this 4 times, doing 2 times is going to be faster, so I'm going to say all this is equals to 1 minus probability of x being smaller than 2, which is equals to probability of x equals to 0 plus probability of x equals to 1. Well, that's smaller, right? So when I figure that one out, probability of x equals to 0, you will get combinations of 0 out of 5, 1 over 6 to the 0 exponents, and 5 over 6 to the 5 exponents, plus combinations 1 out of 5, that's equals to when x is 1, 1 out of 6 to the first, and 5 out of 6 to the fourth. And we can tell This part right here, 0 exponent, this is going to be equals to 1. This combinations also gives you equals to 1. So it will be just same as figuring out this part. Plus that you will get, let me just write it. What does the combination 1 out of 5 means? And then multiply by 1 over 6 to the first, 5 over 6 to the fourth. This gives you somewhere close to 1 minus 0.804. So again, probability of x greater than or equals to 2 means 1 minus 0.804, so it will be 0.196. Okay, example 4, I wanted to show expanding this in 2 ways. The one is going to be using mathematically distributing, which is the foiling method. The other one is using the binomial method. Okay, so let me show that here. So when you have q plus p cubed, this means you have q plus p times q plus p times q plus p, right? And when you do first 2 multiplications, you will get q squared plus, and then do the foiling, right? And then you do the same thing on the outside, and you're going to have the like terms. So it gives you 2pq, and then plus p squared is what you're going to get. And then you're going to distribute this. So this become q squared times q, so will be q cubed, plus that become pq squared, and then this multiplications to q is going to give you 2pq squared. This multiplications with p, you're going to get plus 2p squared and cube, and then you will do p squared times q and p squared times p. So you're going to get plus p squared times q and plus p cube. And then look, you can tell this is the like terms and this is the like terms. So when you combine it, you're going to get q cubed plus 3p cube plus 3p squared cube plus p cube is what you're going to get, right? So this is what you're going to get when you have cube of p plus q. And this is just the regular multiplication method. But if you use the binomial method, you will end up getting the same thing. So this one, binomial method, we wanted to get combinations of 3, 0 out of 3, right? And it means success is going to be 0 and failure is going to be 3, plus combinations of 1 out of 3, success 1, failure 2, plus combinations 2 out of 3 this time, so it will be 2 and 1, failure, and then plus combinations of 3 out of 3. So this time your p is going to be third, q is going to be 0. So this gives you, this is going to be 1, this is going to be 1, so you have a q cubed remaining. This right here is going to become 3, so it will be 3pq squared. Well, that should be squared too. And then plus, that's another 3. So it will be p squared and q. Plus, this is going to be 1, and this is going to be 1, so pq remains. So either way, binomial formula method or multiplication method, you should be end up getting exactly same thing. And that's what I wanted to show. Example 5, suppose a fair die is rolled 3 times and success on the single roll is considered to be rolling a number divisible by 3. For the binomial distributions, A, write the probability functions, B, construct the table, C, histograms. So you're rolling fair dice. It means you have 6 outcomes 3 times. So your n is going to be equals to 3. So let's start writing down the informations. N is equals to 3. You have fair dice, so 1 through 6. But out of 1 through 6, the success is going to be getting a number that's divisible by 3. So it will be either 3 and 6, right? It means your probability of getting 3 or 6 is 2 out of 6 numbers. So that gives you 1/3. It means your failure is going to be 1 minus 1/3, which is 2/3. And getting a B, which is constructing a table, you have 4 options. First one is getting none of 3 or 6 when you're rolling 3 times, 1 times, 2 times, and 3 times. And let me see if we can find out that probability each times. So getting 0 time is going to be a combination of getting 0 out of 3 rolling. Success is going to be 1/3, which is going to be 0 times. Failure is 2/3, which this means getting all 3. So that gives you close to 0.3. Follow that. This is going to be a combination of 1 out of 3, which is 1/3, 1, and 2/3. 3 minus 1 is going to be 2. So this gives you about 0.44. So follow that. The other two will have 0.22 probability and 0.04 probabilities. With that, let's see if we can draw the table. So getting a 0 will be 0.3. Getting 1 will be 0.44. Getting 2 is going to be 0.22. Getting 3 is going to be 0.04. And that's how you're going to construct the histogram for example 5. So then example 6 is asking to compute the mean and standard deviation for the random variable for example 5. We just work on it. So again, let's see, n is equals to 3, p is equals to 1/3, q is equals to 2/3. Your mean in binomial distributions, you're going to get n times p. So it will be 3 times 1/3, which is going to be 1. So that's going to be mean of that problems, example 5. And if we wanted to get standard deviations of binomial distribution is going to be square root of n times p times q, which is going to be square root of 3 times 1/3 times 2/3, which gives you close to 0.82. So don't forget how to find the mean and standard deviation of binomial distributions. So this is the formulas. And you should be able to try the next problem using these examples. Example 5 and 6, because it's same problems with different numbers. And you can find your solutions from the class notes.